Thank you, everybody, for taking the time today during the Worth Construction Services Virtual Supplier Day. My name is AJ Strangquist, and I'm with Ben Cybulski. We're both from the Worth Additive Group. We're excited to be here today to talk to you a little bit about not only what Worth is doing with additive, but in the world of construction, how does additive and 3D printing play a role, and how some of you might be able to enter that arena as well.
Yeah, absolutely. Uh, my name is Ben Swilsky. I'm the director of sales for 3D Group. Alongside what AJ just mentioned, we're just going to kind of go into some of the misunderstandings of construction 3D printing. A lot of people, are jumping ahead of where the technology is. So we're going to kind of bring it back down to a base level and go from there. Uh, So first, we all got to go through, who Worth is, and that is we're supply chain experts. We're family run. We've been in business for over 75 years, but what we really focus in on is finding solutions that work for our customers and our partners. So one of the things that we've done over the last 5 years is invest. We invest heavily into new technologies. So I believe we did about $1 billion globally, $400 million within the US, and part of that was in an additive division. That additive division was starting in Des Moines, Iowa by AJ Strangquist, our CEO. And AJ, maybe you want to talk about the humble beginnings of our additive division and how we've grown to where we are now.
Sure. I mean, we always just had our customers having the same issue, which was, we had great products and services when it's a high run usage or PPE or MRO items, but those really unique one-off special items that dominate people's tool cribs, especially if you have a very kind of long tenured manufacturing site, you have a lot of different equipment you have to take care of, is those were the replacement parts that would pull our customers' hair out and ourselves because we, of course, would want to help them find it. But when it's a machine from France from the 1980s made for packaging, air compressors, getting replacement parts for that machine isn't always the easiest thing. So we started to not only take our customers' prints and helping them recreate them, or, we would have an idea for an improved fastener, and we wouldn't have a very good way of conveying it to our customer except with a drawing. And with 3D printing, we're able to go and show them what that new linkage, what that new assembly could be or perform like. And all of a sudden, they could see that added value, not only in how we were servicing them, but how we can bring our expertise to the field of industrial supplies. With that, it's grown where now we supply equipment, materials, and other engineering services for everything from education to government contracts, large scale OEMs. We're seeing adoption across the board as people try to figure out how to use this new technology and innovate.
Yeah, and I think that's really why we're here is we've been seeing adoption in the construction sector of our business. And we've gotten a lot of questions, and it seems like where they are now as a whole is where industry maybe was, a decade ago in terms of adoption, but their technology is a little bit different. The use cases can be similar, but everything's a little bit bigger, a little bit different. And we'll go into it, but I think there's going to be a lot of lessons that we've learned to apply. Admittedly, we're not the experts on this when it comes to constructions, but within the Worth Group, we do have access to them. So we hope we can do a good job of representing the topic. Throughout North America, we built a pretty thorough team. So each black dot you see on the screen is where we have a 3D printing center, as well as an engineer who is an expert in 3D printing. Again, admittedly, this is more geared to our industrial customers with their expertise, but as we're expanding into different areas of our business, we are looking to expand into different, experts. We have 110 locations in the United States, and our mission's pretty simple. We're here to help support, implement, and really enable our customers to utilize digital inventory within their supply chain. This could be from the tools, fixtures, different MRO parts that AJ would mention to, full-scale production. It really doesn't matter what they're trying to do. It matters, if it's a good solution for them. We offer a lot in terms of what we could do for our customers, from machine sales to rentals to just printing printed parts, sample parts of models. That's something we'll touch on later on in this presentation that could be useful for you guys, as well as servicing machines, basic education and workshops, financial services, and then all sorts of engineering and technical services as well. AJ, maybe you want to talk about our customer base and kind of what we've been going into and we've seen from them.
Oh, I think it's just a theme that we see is across automotive. Um, Again, those other sectors that we hit on, and you can see on the page is um, everybody's looking at this technology, trying to figure out how to maximize it for them. And that's where I think we'll talk about a couple different things in construction, that it's not always 3D printing buildings, as we'll talk about, but it's prototyping new linkages, new assemblies for steel work, trying to restore classic architecture, everything that you're going to go into a bit more detail. But what you see is a lot of common themes where people are trying to cut down their time of development. They're trying to make it easier for new ideas to come to life. And then operationally, they're looking for those tools and items that help them save operational cost and time and things like that. So it's more similar to other technologies, as we see it affecting all those different industries because it has an inherent value for essentially most businesses.
Absolutely. So now we're going to get on the topic at hand, which is construction 3D printing. First, we're going to address the topic of 3D printing buildings, which most of you are probably familiar with, but don't have an expertise in. We're going to talk about different technology that's available that's related to 3D, that's very prevalent within construction, as well as modeling and different types of tools that could save time and money. So first thing we want to talk about and just throw out there is, how many of you know how many houses have ever been printed? You probably know that buildings can be printed, but do you know the number? And AJ, I know you do know it, so maybe you just want to spoil it because there's not any guest feedback on this feed.
Yeah, well, yeah, I mean, I guess we can have like the Jeopardy music run as people think about it. But I think that there's a whole lot of hype around it and all the advantages. And I spoke to the president of the world's leading 3D printing construction firm, Cobod, and he gave me the factoid when I said I think there's a couple thousand 3D printed buildings out there. He gave me a reality check that truly there's around 50 freestanding buildings that were 3D printed worldwide. And so while the promise of the technology and its impact is definitely there, there's a lot more maturing when it comes to building regulations and longstanding performance. And for instance, a lot of times you need a structure or material to stand for 10 years before it can be officially approved to be load bearing or something like that. There's a whole lot of maturing there, but I mean, that doesn't defeat that there's a lot of inherent benefits to 3D printing some buildings.
Yeah, absolutely. And the thing to take away from it, this is what everyone talks about when they think about, construction 3D printing, but it's one of the least utilized. It's still an emerging technology. Later on in the presentation, we'll get into the technology that's really being utilized and picked up to help with safety and efficiency. But just know it's still an emergency technology. Generally speaking, these buildings are printed of concrete, one layer at a time on top of each other. You could think of it as like a hot glue gun going over itself and over itself. Right now, you cannot print a full building. You could print a foundation in some cases you can't. And you could print the frame and walls. So it still requires, electricity, plumbing, a roof, all of that stuff. You can print a bench on the inside, things like that. You can print landscaping, interesting design features, but not the full structure just yet. What's interesting about Cobod, you mentioned that they're the leader. They did print the first two-story building in Europe, which is a huge leap forward for this. To be able to print a floor is pretty impressive on a two-story building. Granted, these things aren't, mega buildings. They're not skyscrapers. They're very small. But this proof of concept, this adoption is happening, and it's something to pay attention to. Another big part of it is the cost. Relative to a lot of other forms of traditional construction, this is an inexpensive process, which we'll get into where that may fit later on. So let's take a minute and talk a little bit about the advantages. The picture on the screen is one of the most famous 3D printed buildings because it was done in South by Southwest in Austin. They printed this in like a day, and it cost, I think, like $10,000. All of that is great, but it was set up to do so. In reality, there's a lot more stuff involved with getting a house printed, but as far as the actual build time, it was in about a day. The cost is about $10,000. Still, relative to other forms of construction, it was inexpensive. These are being marketed and they are very eco-friendly. So a big part of this is looking for a means of constructions that's sustainable, that is a low carbon footprint. Uh, Other benefits of it, it's very scalable, it's modular, you're able to repeat the same time as long as the foundation is the same over and over and over again. You don't have to reprogram it, you can simply move the device over and hit go. Uh, a lot, and maybe AJ, you want to touch on the design flexibility because that's where we're really seeing the impact of these being used as, as opposed to other areas.
Yeah. So the example that you might use, like that, coming from our core, which is industrial supplies and industrial 3D printing parts, is 3D printing a wrench usually isn't a great return on your investment because wrenches are quite easy to get, mass manufactured at a great cost. Similarly with buildings, is it's not prohibitively expensive to build straight lines. That's what we're pretty good at, is making those awkward rectangles stand up. What is prohibitively expensive in traditional construction is curves. So curves aren't free. It's the opposite. Curves cost a lot of money. And so when you see the design flexibility, what it is it does you very little good to have a large square building be 3D printed because now your costs are only being compared to that um, mass produced home or traditionally produced home. But all of a sudden, if you're using organic shapes, you're building in these additional features that can only be done with 3D printing or done cost effectively. All of a sudden, your return on the technology is much higher. Is it's no longer a champagne solution for a beer problem, it's a champagne solution for a champagne problem.
Yeah, absolutely. And we're seeing this heavily adopted in areas of the Pacific Northwest within the modular home scene. Even outside of the construction 3D printing, just regular conventional plastic 3D printing, we're seeing people make larger feature walls and then utilizing that in their home to kind of distinct or have a something, that jumps off the page for a potential buyer that's very unique that helps draw them into their brand. Another part of it, we touched on it. They're relatively fast and they're very efficient. They don't use very much concrete. There's very little waste. Uh, when you think about an additive process, it's just that you're adding material as you go. Subtractive processes are where you start with a large block, let's just say concrete, and then you'd sculpt out what you want. When you sculpt it out, you do have waste. This is a low waste. It's why it's eco-friendly, helps it be sustainable, makes it more efficient. So let's talk about the downsides. There is an initial investment for the machines. They are not crazy expensive, but they're not cheap either. Still, as these are becoming more regular, the machine costs are expected to go down. The two biggest parts of the downsides are the rough exterior. So you could see on the screen a picture of a 3D printed wall. Now, what you can see the nozzle, which is the gigantic silver thing, and the layers being printed. So they'll print in layers roughly as wide as your phone of concrete, and they stack them on top of each other. This is a wall they chose to take a picture of. So this is pretty good. Other walls may not look this good. The truth of the matter is the technology is still emerging, and you're going to have rough features around it. So for a consumer, it may not be as polished as you would normally like. The largest factor, and AJ touched on this earlier, is the lack of certifications around the buildings. So for most commercial structures, or all, it's really not super there yet. And the other part of it is, of course, you're just dealing with partially built buildings. AJ, is there anything else you think for the downsides of construction 3D printing?
Oh, don't try to, a tool shed, a 3D printed tool shed that's a cube won't do you much good. But I think there's a couple things. One is you can tell with the layer lines people that do work in concrete quite a bit. You can see where they actually stop the process for a good chunk of time as the gray color gradient on the concrete here changes. So, for instance, there are people like, again, I mentioned Cobot because they really have developed quite a few processes where they actually add a planing feature to the nozzle to help reduce that. Um, and I think the downside is just using an overly engineered solution for a simple problem. But that's when you start to go is when you're printing complex shapes like the curve that you see, or you're in really adverse environments, like it would be much nicer to send two people into the desert to produce a shelter or maintenance bureau or whatever it might be for your oil field or your wind turbine field, whatever. It's much nicer to have those folks in a harsh environment only have to be two people with their trailer, with their gantry system and their concrete, as opposed to a team of people, numerous trucks, all those consumables. You have to keep track of it. And oh, yeah, if you forget something, you're running all the way back to wherever the nearest depot might be. So, no, I think you did a great job of outlining that.
No, absolutely. And so, where does this fit, at least right now, present day? Temporary structures, kind of like you were outlining, they're a great fit. In harsh environments, this could be a really, really good fit. Military applications, that's a huge adopter of this. So the military doesn't have to deal with as much regulations as civilians, and they would have a need for small structures. Now, this could be for housing, barracks, but it could also and is used for training. So if you wanted to build unique facilities to model a particular village or something that you may have special forces going into, you can actually print the structure to do the training within it to be relatively accurate. Utilizing that, and later we'll talk about VR, similar type technologies, you can get your soldiers prepared before you get your boots on the ground, giving them a small advantage. Uh, Community outreach. This is where we're seeing it used in the civilian market. It's if you read into the South by Southwest or most of these U.S. based construction 3D printing companies, they're focused in on trying to solve the homeless problem with it. In this situation, cities are willing to waive a lot of the building permits and a lot of the regulations around it in order to try to help combat this problem. It's in areas like Austin, Texas, that you're seeing small, like micro villages being built and 3D printed. Again, there's not a ton of these out there, but that is something that, an application and use that we're seeing coming forward. As far as in more commercial settings, definitely adding unique building features, whether you see the staircase over to the left, which is just unique looking, to different types of landscaping features, whether it be different complex exterior walls, stuff that would be cost prohibitive to do potentially with masons, you could do with a 3D printer for relatively cheap and add that extra, spice to the product. And parks are a big, we're expecting to see a big jump in adoption for similar reasons for the community outreach. Now, we don't see them building the buildings out of them. We see them using them again for features and landscapings and things like that. AJ, where else would you say this technology would typically fit?
We hit on it a lot. Is the potential is you see it in large scale, art installations. You see it in buildings. You see it in emergency response. You can see it in flexible design. I mean, there's a whole lot to it. It really comes down to, one is probably the folks that we're talking to, performing the sniff test of how do you make money? Does this serve? Does the customer want this? All those features. But as you add it up, it gives you an amount of flexibility that doesn't. It gives you such a great amount of flexibility with such a little amount of physical labor that it's just going to take a matter of time before materials are certified for it, and the process is code compliant, which it is in the case of places like Germany, which has extremely strict building code and regulations. There are people living in those homes, so it did pass those inspections. The question is getting the cost correct, making sure that inherent value of building in your kitchen with the design of the exterior walls, or building in your grotto or your hot tub, or whatever your mind kind of builds. Is you have to start thinking, I can do this, that, and the other thing, and it's not going to cost me extra money. I can have an indoor outdoor swimming pool with, part of it is this tall, and I have my family crest etched into that, and all this other stuff. It it's the same complexity if you want to make the line straight as if you want to make it a zigzag and come around the corner and all of that. And that's where I think people have to start thinking about that, because you're going to see shapes and designs that customers will pay that premium for, where the cost isn't a problem anymore.
For sure. And I would love to have a family crest at some point. Uh, so, related technology to 3D printing that is probably more applicable than 3D printing itself. 3D scanning. This is by far the most adopted and most used. So, scanning technology has come a long way. Uh, what we're seeing is are people who are using it not only to scan and reverse engineer parts, but to scan entire buildings, interiors, exteriors, plumbing, HVAC system, everything. And using them to create CAD files, using them to create 2D drawings, utilizing them to create a VR environment to either compare what you wanted, your current state to what your design is after you're done with your construction, to safety. We're seeing a lot of people, yeah, utilizing this type of technology where they're mapping it out, creating the VR environment, and they're going through an operation with a person. And I'll have AJ give a good representation of what one of our customers is doing. But let's say if you had to get very high in the air and do something critical, you want to rehearse that. Much like I said with the special forces earlier, practice, practice, practice. It gives you that advantage and it reduces your risk. So we're seeing people map this out. And for those kind of, you know, say a crane operator where you have something really specific and critical, they can relive that and do it time and time again before actually going into it. And AJ, I know you had a really good example of this. Do you mind telling the crowd?
Yeah, I mean, for me, is in our world, we're so decentralized, and our customers are all global and could be decentralized as well. Where if you can provide that training and in an environment where it feels hands-on, without you having to ship physical products all over the world and have all of that cost associated with it, it's very powerful. From North America with our team of experts, we're actually helping a customer with 7 sites that are outside of North America. So that same team is utilizing things like virtual reality goggles, and things like you're describing here, to work live with those folks. So you're able to have this high skill set or something that's very unique, and yet be able to train and implement it very easily worldwide. And that's where the training and the safety in construction is so mature, and there's stuff that it'll take us years to understand the depth of that scope. But if you go to the next one, I think that's where I feel like, as you're actually building, right? Not so much the training of it, but Ben, talk a little bit about what you have here, where people are actually like during a build using those 3D renderings and things like that to ensure that, you have good project planning, you have good vision, you can kind of adjust on the fly, things like that. Can you kind of
Yeah.
describe what's going on?
So the example up here to the top left is an entire building in London that has been utilized, like 3D scanned inside and out, and actually got it created a full VR representation and a full CAD representation that they're able to use the 2D drawings for. What you could do with those is you're able to put them in and take your building site, then see where you're at, and then transpose what your final product is on top of it. So what do you want it to look like? So you can make sure that everything is correct, and actually measure via the software to see that this beam is where it should be. This is going to be able to fit. So you can kind of troubleshoot issues before they come up. Another part over here is if maybe you're working for someone, they're interested to see progress, you're able to help show them easily on what this will look like. So instead of having to kind of explain to your customers, explain to people what's going on, you're able to kind of educate you by just visually showing them where the project's at and what the next phases could be. This technology is readily available. It's utilized. You guys are probably utilizing it now, but it's one of the aspects of 3D to say that is more prevalent in construction, and it's just one of the coolest things. The other thing is this reverse engineering. And AJ, maybe you want to take this one away because I know you talked to someone who has a similar problem.
Yeah, I mean, you're looking at some beautiful craftsmanship on a bridge in New York City, where, for instance, one of our customers that is based out of New York City um, have the task of trying to recreate some of this beautiful architecture, right? There's plenty of buildings that need to be repaired or restored. And yet you have craftsmanship from 100 or more years ago that's either extremely difficult or near impossible to recreate. And so what technology is doing for those folks is now you can walk into that site, take a high fidelity scan of the location, all of the features down to a very fine detail. Well, let's say you do have to recreate it, is you can now take portions of it and send it to a machine shop to help recreate or a craftsman. There's portions of it that you might replace with additive, but the biggest one is you're using that new technology and doing in a restoration project like this is trying to recreate as close as you can to that original, beautiful craftsmanship that got put into it.
And where you may use additive is not the final product. It might be the model of the product. You may
Right.
utilize this to generate the model to then show someone, hey, this is the specific section we need work on, and then here's everything along with it. So again, just accelerating the understanding while you're trying to explain this to people. Visual representations, tangible things usually help. And we'll go into that part later, but that was the early beginnings of our additive group. We're simply making prototype fasteners, not to be used, but just to get into our customers' hands so they knew what we were talking about. And that's what we're talking about right now. Put it in their hand. Creating a model of what you want to do is very impactful. It's very cheap, pennies. It is extremely inexpensive. It is a great way to start with additive manufacturing. You're able to learn it at your own pace. You're able to use it to help accelerate your sales, help with customer understanding, and you're taking something from a drawing and making it tangible. And the vision for our group really did start with AJ in Des Moines doing just this. Uh, and since then we've grown. We've grown substantially to helping enable customers. And AJ told you the story earlier, but when we're seeing people reach out to us, not about, concrete 3D printing, not about reverse scanning, they want to just make some models for their customers so they can put this part that they've tried so hard to explain to John, and John just isn't getting it. And they're just like, could you help me make this? It's really simple. We look at it, sure. You hand it to John, and John's like, I get it now. That's fine. Uh, that is a unsung use of 3D that is, wildly cheap and very impactful.
Sure. I mean, imagine if you're trying to challenge an architectural firm, is you could have them quickly iterate on those models of the thing you're working on and have those changes, and again give you that and slide that model across the table. And as I understand it, when it was all handcrafted and put together, those types of live models, it's pretty cost prohibitive, right? But now, if you want to go ahead and print that entire kind of small community and include the trees and the park bench and all of that detail, it's no longer somebody putting miniatures on a page. It's they change the 3D CAD file and they hit print, and now you've got a great landscape of what you're trying to build. So, no, and to your point, is sometimes it costs pennies, like at the fasteners, but then in some industries, maybe you invest in a full metal part, right, where that process is a little more expensive, but they're dealing with heavy metals, they're dealing with a lot of impact, and they want to may have that fully melted steel, that full wrought steel, to help prove their models, which again may not cost pennies, but it's still a fraction of the cost compared to trying to recreate it by getting molds made and tooled up and all of that.
Definitely. And one of the last applications is 3D printing tools and any type of job aids. So where we see this being used in industry and construction and just pretty much everywhere is custom assembly tools. Things that are, maybe you need for one job. Maybe before you weren't going to go to a machinist. Maybe you didn't have a CAD file. Now all of that is unlocked to utilize so you can make stuff more efficient. You can make stuff safer. We've seen a lot of applications within OSHA compliance. AJ used to give a great example for oil platforms where they'd be carrying up, a large metal wrench to help tighten some fasteners. And the idea that now you can make that same wrench to do that same job out of a composite, perform the same, but if God forbid it drops and falls on someone's head, well, that thing weighs a lot less. It's also a lot less expensive. And because you have another printer on site, you're able to reprint the replacement and get yourself up back running. Things like that are really where we're seeing adoption in all sectors. Welding aids, anything related to welding with printing high purity copper is going to be a very big application for us. And then machine repair. Coming back, it depends on what level you're doing. A lot of OEMs are supporting their machines, obviously, but maybe you do have that French machine that AJ referenced, and maybe you do just need a lever that has a unique geometry, and it's going to cost you $3,000 in a month to get. Well, you could just probably print it, and it's going to cost you $3, and it might take 4 hours. That's where we're seeing a big fit, and that's where also we think it would be good for the construction industry.
Agreed.
And then with that, we'll happily put some of these on site for you guys. And AJ, if you want to talk a little bit more about this before we say goodbye.
Yeah, I think it's more, as you've probably seen our Worth containers, is we want to serve our customers the way they want to be served, and it sometimes that means being a little creative. Is so that Worth container is kind of a standard program. We'll go onto your job site and have your consumables and different materials inside of it, and once the job's complete, we can pull it out, and we have all sorts of little tricks that we can do to make it easier and fit your buying needs. But I think that, yeah, as we approach things like oil and gas and renewable energy and people doing construction or a lot of work in very far off or remote locations, is to be able to have all that manufacturing flexibility on the job site with you is a really powerful idea. So for us, is we're trying to bring the same kind of eye and the maturity that we have in our core business of industrial goods, getting to the point where we have custom made shipping containers to help serve our customers, is we're trying to apply a lot of that same thinking with additive, right? And kind of not make a 1-year jump in the future of how we try to think about, inventory management, but how do we make a 5 or 10-year jump and how you think about inventory management. And this is one of those ways we humbly think is thinking ahead.
Absolutely. And with it, that's really all we have. Guys, just like to thank the Worth Construction Service Virtual Supplier Day for your time.
Nailed it.
If you guys want to immerse, analyze, plan, approve, execute, and review anything, just give us a call. We're here. Email any questions you guys have. We're happy to take one-on-one calls. And if you want to talk to an engineer, we got them.
No, and we really appreciate everyone's time. And part of this follow-up, we'll have our contact details and any regional reps, but feel free to reach out to your local Worth representative as we work hand in hand. And again, thank you so much for your time. And hopefully today we were able to showcase a couple different things going on with additive manufacturing in construction, and then also how our core customers are using it to save time and money as well. So hopefully you found it helpful, and look forward to having some time with you again. Appreciate it.
Thank you.